we need to learn what are the different forms in which the dynamic equation for gradually varied flow can be written. One equation we have already derived, that how we write it. The general equation is dy by dx is equal to S naught minus Sf divided by 1 minus q square t by GAQ. So this is the first and the general equation which we have already seen. Now this can be written in different manner, because in some for doing numericals what happens is sometimes this SFG q square t by g square won't be directly given, so it will be given in some other format. So during that case we have to use the different forms. I've already said that this q square t by GAQ is nothing but the square of roots number. So the next form is dy by dx is equal to S naught minus Sf divided by 1 minus Fr square. Now coming to the fruits number, if you consider it for a rectangle channel, most probably you will be getting the question for rectangle channel. So fruits number is nothing but V by root of G into D, where D is equal to A by T. And for a rectangular channel, this A is equal to B into Y, and top it is equal to B. So what you get is, you will get D is equal to Y itself, your hydraulic type. So the fruits number for a rectangle channel is V by root of G y itself. So the fruits number square of fruits number would be V square by Gy. So if I substitute it here, this equation becomes dy by dx is equal to S naught minus Sf divided by 1 minus V square by Gy. This is yet another form. I'll be saying this is a third form. Now coming to the Sf. S naught, generally it will be given the question. Now coming to Sf, how to calculate Sf. So there lies a question. Sf, the Sf is being calculated on the basis of the discharge equation for non-uniform flow, and we have got two equations. Q is equal to A by N R raised to 2 by 3 Sf raised to 1 by 2. I'm repeating, this is for a non-uniform flow, and this equation is the Manning's equation. Now if you are using Chessy's equation, you will get Q is equal to A into C into root of R Sf, root of Sf. So from these two equations you can find the value for Sf. So if I cross multiply, I get Sf raised to 1 by 2 is equal to Q by A, N goes there, R raised to 2 by 3. From this equation I can write Sf raised to 1 by 2 is equal to Q by A C into root of R. Now what I need is, just 1 second, this Q by A is velocity, so I can convert this to be velocity. So I'll get V N by R raised to 2 by 3. This is the value for Sf raised to 1 by 2. So if I square it, I'll be getting Sf is equal to V square N square divided by R raised to 4 by 2. I'm squaring on both sides. Similarly here also Q by A becomes velocity. So this is equal to velocity by C into root of R. So that is Sf raised to 1 by 2. So if I square both sides, it becomes V square by C square R. So there comes the next. Instead of Sf I can substitute. Instead of Sf I can substitute either of this value. So if I am using Manning's equation, I can write dy by dx is equal to S naught minus Sf will be this V square N square by R raised to 4 by 3 divided by 1 minus V square by Gy. This is one format. Or the fifth format, when I am using Chessy's equation, I can write dy by dx is equal to, see in this equation S naught is there, S naught minus, instead of Sf I can substitute this V square by C square R divided by 1 minus V square by Gy. This is the fifth equation. So these 5 types of equations I'll show. This is the first general equation. Then this is the conversion for Q square T by GAQ. Now when I substitute the value for Fr, I'll be getting this equation. And for substituting the value of Sf as per the Manning's equation, I'll be getting the fourth equation. And I'm substituting the value of Sf as per the Chessy's equation, I'll be getting this equation. This is used when Manning's equation is used. This is used when you are using the Chessy's equation.